Hello and welcome to this R tutorial. In the previous sections we already introduced two nonlinear regression models, the polynomial regression model and the SVR regression model. And today we're going to introduce a new nonlinear regression model, which is the decision tree regression model. So far the best model we had for our data set and our specific problem was the polynomial regression model. Let's see how decision tree regression will do and compare it to the previous ones. So let's start with the basics. Let's set the right folder as working directory. So right now I'm going to the regression folder and we are now in decision tree regression, almost getting to the end. So this is the right folder containing the position salary CSV file, make sure of that, and click on this more button here and set as working directory. All good. And now let's take our regression template to build this model efficiently. So we take everything from here to here and pasting it here. Right. And now we just need to change a few things. So let's change the basics. Let's replace here regression model by decision tree regression. All right. We're going to copy that and put that same title here. All right. Visualizing the decision tree regression results and same here. All right. And now let's change the most important thing, which is the part where we create our regressor. So I'm going to remove that comment line here. And now let's build our decision tree regression model. So it's going to be the same thing as any time. We're going to import a package and then use a function from this package to build our regressor. So this package for decision tree regression in R will be the rpart package. For those of you who don't have the rpart package in your packages here, I will type this command line so that you can install it. So as you can see, mine is already here, rpart. Just check if you have it, and if you don't have it, just type here install.packages, and then in the parentheses in quotes, you type the name of the package, which is rpart. All right, and then you just select this line, execute, and this will install the package. All right, but I'm going to put this line as comment. Just press Command plus Shift plus C. And now let's also add this line library and then parenthesis the name of the package we want to select. Well, import rpart, right? And as you can see, rpart is not selected here. And when this line of code will be executed, then this will be selected here. All right, and now we are ready to start building the model. So as I just said, we're going to take a function from this rpart library, and this function is actually rpart as well. So let's use this function, and as usual, we're going to call a regressor. So here it is. So that's our decision tree regression regressor. And let's now use the rpart function. All right, so now let's see what arguments we need to input. The best way to do that is to press F1 here so that we get the info about the rpart library. So usually we have it here, but now we just need to click on this link here and that will give us info about this rpart library. Okay, so let's see what we have. The first argument is formula. So you know what to do here. We just need to write formula equals the dependent variable, then a tilde, and then a dot that represents all your independent variables. All right, but that we know perfectly. Then data. So data is the data set on which we want to build our decision tree regression model. So since we did not build any training set, data is going to be the data set, exactly like polynomial regression and SVR regression. All right. Then weights is an optional argument. You can add some weights to make your model more advanced, but you know, this is more advanced, so we will not cover that right now. And then you have some other arguments that are optional, but that can help you make your model even more robust, or you know, include some regularization techniques or penalization to prevent overfitting, that sort of things. But right now we just want to build a simple decision tree regression model because we have a simple data set, and so we only need formula and data. So let's go back to R and let's input these arguments. So the first argument was formula. And then, as I mentioned, it's formula equals salary because it's our dependent variable. then tilde, just pressing Alt N here, and then a dot, or actually level. But, you know, I want to make this script that can be also applied to your data sets, so I'll use a dot. All right, so that's the first argument. And now let's give the second one. The second one was data. So data equals dataset. And now our regressor is ready to be built. Only with these two arguments, very simple, let's do it. So it's ready to be built, and that means all our code is ready to be executed because we don't need to change anything more. So let's execute the sections one by one, and let's see what happens with decision tree regression. So I'm going to select the first section, execute, dataset 1 imported. Here it is. So the independent variable contains the 10 levels here, and the dependent variable contains the 10 salaries here associated to these 10 levels here. And our goal is to predict the salary of a 6.5 level. The data is not linearly distributed. This is not a linear problem. So that's why we're making some nonlinear regression models to make this prediction. All right, so then no need to split the dataset into a training set and a test set, because as you can see, this is a very small data set. Then no need for feature scaling, because for decision trees, we don't need to do any feature scaling because the way this model is built is based on conditions on the independent variable and not on Euclidean distances. So we're fine with that. We definitely don't need to apply feature scaling, and we can move on to the next step, which is to create our model. So let's create it. Executing. All right, perfect. Regressor is created. And now let's get our final verdict. Okay, so 160K according to this person. And now let's see the predicted salary according to our model. So executing this, and we get a $249,000. Wow, much higher than the salary mentioned by this person. But let's not drop hasty conclusions, and let's see what's happening on the graph here. So I'm going to select all this, and let's see what's happening with the decision tree regression results. All right, that's what I thought. Okay, so we don't need to zoom on it. We clearly see what's happening here. It's plotting a straight horizontal line, exactly like we saw in SVR, but for Python. For those of you who didn't follow the Python tutorial, know that we already encountered this situation when we get a straight horizontal line. And actually in SVR, this was due to the fact that we didn't apply feature scaling to our dataset. So what do you think the problem is here? Do you think it's due to the fact that we didn't apply feature scaling like for SVR, and we need to apply feature scaling to get a model fitting properly the dataset? Well, as I mentioned in the beginning of this tutorial, we definitely don't need to apply feature scaling for decision trees, because decision tree regression models are based on conditions on the independent variable that has nothing to do with Euclidean distances. And you know, when we need to apply feature scaling, it's because the machine learning models are based on Euclidean distances, and we need to put all the independent variables on the same scale so that one independent variable is not dominating another one. But this is not the problem here. This is not about feature scaling. You can try to apply feature scaling here and re-execute this, but you'll get the same problem with a straight horizontal line. And of course, this is actually the decision tree model. This is actually one model of decision tree, but this is of course not the best version of decision tree regression we want to get. So can you start seeing what's the problem here? And especially after watching the intuition tutorial made by Kirill, can you spot the problem? Okay, I'm going to tell you this problem is related to the number of splits, because, you know, the way the decision tree regression model is made is that it's making some splits based on different conditions. So the more conditions you have on your independent variables, the more you have splits. And here, we clearly have no split here because, you know, all the predictions are equal to $250,000. So, you know, it took all the different salaries for the different 10 levels here and made an average, and just gave the average for all the levels. So no conditions here, no split, and therefore that's absolutely not interesting, especially for the potential that decision tree can have. So what we'll do now is add a parameter here that will set a condition on the splits. You know, that's what I was telling you. We have several parameters in this rpar library, and we can use these optional parameters to improve our model and make it more robust. Well, this is exactly what we're going to do now. We are going to get back to rpart. So I'm going to press F1 here. Oh, actually this time rpart is showing up. Okay, so great, rpart is here, and as I mentioned, rpart has several parameters that we can use to make our model more robust. And the one we're interested in right now is one parameter that will correct this problem we had with the splits. So this parameter is actually the control parameter. And right now I'm going to give you a little trick to solve this problem on the splits we had just obtained here. So I'm going to add this third optional argument, you know, to improve our model. Right now we're doing some model performance improvement, so that's a thing that machine learning scientists do very often in their job. So don't worry, we'll get more advanced sections on it, especially when we cover cross-validations to find the best models, selecting the best parameters. But here we will just do some simple model performance improvement, and we'll just add this control parameter, and then I'm going to give you this little trick. So this little trick is to take the rpart library again. So we're taking rpart control here, which is a function. And in this function, we're going to add an argument. As you can see here on this yellow rectangle here, we have the first argument that is min split. And that's exactly what we're interested in. And that's what will solve our problem. Because, you know, actually we didn't have any split here because it just took the average. So it's like we had no conditions on the independent variables, so no splits. So to make sure we have some splits and some conditions on the independent variables, we will actually set min splits to 1. And that will solve the problem. So let's try. Let's now reselect this section to create a new regressor. So rpart is already imported, so I don't need to select that again. And let's create this new regressor. Okay, done. Perfect. New regressor created, all properly. Okay, and now let's perhaps first visualize the results to see if our model is now correct before getting to the final verdict, because, you know, we need to validate the model now. So I'm selecting this section and let's see what we get. Let's cross our fingers. Here we go. I'm going to zoom on the plot. And now the first word I have to say here is trap or red flag. Right now we're just in front of a new trap. The model is improved. Definitely, we can definitely see that we have more than one split here. For example, here that's a split, that's another split here and here. So okay, we solved the problem of the number of splits. But according to what Kirill explained in the intuition tutorial, do you think that's the real shape of a decision tree regression model? Well, because you know what Kirill explained is the algorithm of decision tree regression is that by considering the entropy and the information gain, it's splitting the independent variables into several intervals. So in the intuition tutorial, you had two independent variables. So the different intervals formed some rectangles in which you took the average of the dependent variable values. But here, since we are in one dimension, that means that the algorithm will only take intervals here of the independent variable. For example, that should be one interval, and here it looks like it's a second one, and here it's the third one, and here a fourth one. Okay, so basically it looks like we have 4 conditions and 4 intervals that are making the splits, but as you understood in the intuition tutorial, it's taking the average in each interval. So if it's taking the average, how do you want to have this straight line here that is not horizontal? Because you know what the decision tree regression is doing is that in each interval, it's calculating the average of the dependent variable salaries, and therefore for all the levels contained in this interval, the value of the prediction should be a constant equal to this average of the dependent variable in this interval. And here, as we can see, it's not a constant. You know, the prediction here is not the same as the prediction here. So either it's considering an infinity of intervals with different constants in each of those infinite intervals, or either we have a problem here. Of course, it's not the first option. Of course, the decision tree regression is not considering an infinity of intervals between this level and this level. So it's definitely the second option. So now do you see where the problem comes from? Well, the answer is in our regression template, because what we observe here is only due to the resolution we picked to plot these decision tree regression results. Because we're actually plotting the predictions for each of the 10 levels incremented by 1. That means that here, you know, it's only plotting the predictions of the 10 salaries corresponding to the 10 levels, and then it's joining the predictions by a straight line here because it had no predictions to plot in this interval here of the independent variable level. And the fact that it's a problem for this new nonlinear regression model, the decision tree model, is due to a very specific reason. For the previous nonlinear regression models, we could use the code that generated this plot because the models were actually continuous. So, for example, in the polynomial regression model, well, between these prediction and these prediction, well, it was actually almost a straight line here. However, right now we're facing a new kind of regression model. Remember, the first kind of regression model we studied was the linear regression model. Then the second kind of regression model we saw was the nonlinear regression model. And now we're facing a new kind of regression model. It's the nonlinear and non-continuous regression model. Indeed, all the previous regression models that we saw, whether they were linear or not linear, they were all continuous. But here, the decision tree regression model is not continuous. And this is the first non-continuous machine learning model we are seeing together. And so do you know what is the best way to visualize a non-continuous regression model? Well, as I was telling you, the answer, the solution for this is in our regression template. So let's have a look. And actually we need to take the code section that visualize the regression model results in higher resolution. So let's take this and let's actually go back to our decision tree regression file and replace this code here, because this is totally not appropriate for a decision tree regression model because it's a non-continuous model. And so we need to replace this code by the same, but for the high resolution. And now let's check it out. The model is actually ready. We can actually replace that by decision tree regression. And now let's check it out, and you will see what the real decision tree regression model looks like in 1D. So let's do it. Let's select all this and execute. And here it is. That's what it looks like. And actually, since it's a non-continuous model, we should even have some strictly vertical line here, you know, to represent better the non-continuity. And to do this, we just need to increase the resolution. So I'm going to put 0.01, and you'll see that we'll get the real representation of the decision tree regression results. So let's do it. Here it is, now almost vertical, and that's a clear representation of the decision tree regression model. So now let's zoom on it, and now it makes much more sense. Because as Kirill explained, based on the entropy and the information gain, it splits the whole range of your independent variable into different intervals. So here we can clearly see where the intervals are. The first interval is from 1 to 6.5. The second interval is from 6.5 to 8.5. Then the third interval is from 8.5 to 9.5. And finally, the last interval is from 9.5 to 10. So there we go. We can clearly see the intervals now. And as Kirill explained in the intuition tutorial, the decision tree regression model is considering the average of the dependent variable values in each of the intervals, this one, this one, this one, and this one. So for example, if we consider this interval here, the average of the salaries in this interval, well, that's very simple. It's actually 250,000. And so for each of the level between 6.5 and 8.5, the salaries will be predicted to be $250,000. So we already know what our model will predict for our 6.5 level here. It's going to predict 250K. So speaking of this prediction, and now that we get the decision tree regression graphic results very well, let's actually check that the previous salary of this employee that had a 6.5 level in its previous company is actually 250K. Let's check it out. Let's select this line and execute. And here it is, 250,000. Exactly like we predicted, because we can clearly see that on this plot. So now I just want to say two things to conclude. The decision tree regression model is not an interesting model in 1D, but it can be a very interesting and very powerful model in more dimensions. So that's why you can use this code here for your data set. You have the code here that builds the model and this one here that makes the prediction, but then you won't be able to use this code because you'll have probably a lot of independent variables and therefore a lot of dimensions. But you know, Kirill gave you the explanation in 2D. I'm giving you the explanation of 1D so that now in your mind, you can perfectly represent in your head the decision tree regression and how it works. And now I would like to end this tutorial by an enigma. In the next section you will see random forest. And a random forest is actually really simple. It's just a team of several decision trees. So knowing that this is the result of one tree, what do you think we'll get with a team of 10 trees? Or even 100 trees? Or 500 trees? The first question is, do you think we'll get this shape of some stairs here? And the second question is, do you think we'll get a much more accurate prediction, like a prediction that is getting very close to the 160K that is supposed to be the real salary? So these are the two questions. I will let you think about that, and I look forward to giving you the solution in the next section.